Today we're going to be learning about how matter can change. And matter can really change in kind of two different ways. There are chemical changes that matter can undergo, and there are physical changes that matter can undergo. All right. Before we get started, oops, I would like you to set up your notebook. All right, this is going to be on page 15 in your notebook. Give yourself a heading at the top, chemical changes versus physical change. And all you really need to do is cut that piece of paper in half. Draw a line right down the middle. At the top of one column, we're going to write physical change. At the top of another column, we're going to write chemical change. And then, give yourself most of the page. And then down maybe the last third of the page, draw a line across so that you have room to write in some examples and even draw a picture there. Okay, so pause this video and go ahead and do that. Okay, now that you have your notebook set up, let's talk about how matter can change. And matter can change in a variety of different ways. So here's just a quick summary of chemical and physical changes. You don't have to write any of this down, but basically if we have a chemical change, right, before the change we have a log. During the change, while the change is occurring, that log is getting burned. And then after, we end up with a new substance. In this case, we end up with a pile of ash. This pile of ash is very different from the wooden log, right? You wouldn't even say they're the same thing. A log, ash, two totally different things. Physical change, on the other hand, before the change, we have a whole lemon, right? During the change, while the change is happening, that lemon's getting sliced up. And then after, we have slices of lemon. Now, are these slices of lemon the same thing as the lemon? Yeah, they are. They're a different shape, a different size. You can see the inside versus the outside, but it's still a lemon. It's still the same thing. And that's kind of the main thing, is when you have a chemical change, you go from one substance to a totally new substance. And when you have a physical change, your substance doesn't change. It's the same thing. It just looks different, tastes different, feels different. Okay. So let's start by talking about physical changes. Here's where you're going to be taking some notes, right, in that physical change column. So the first thing you need to know and write down about physical changes is that physical changes are a change to the physical properties of matter. Remember physical properties, those properties that we can observe without actually changing the matter. So those physical properties like size, shape, texture, or state like solid, liquid, gas. If those things change, that's a physical change. All right, size, we can change the size of a paper. We can change the shape of a piece of paper. I can make a paper rough or smooth. If I have water, I can freeze it, I can melt it, I can evaporate it. It's still water, it's still H2O, it's still the same thing. Another important part of a physical change is that the identity of the matter doesn't change, right? We went from a lemon to lemon slices. It's still the same thing. It's still got the same identity. If I have a piece of paper and I rip it in half, still got paper, even though I changed it, right? I changed that paper, but it's still the same. The identity didn't change. Finally, most of the time, that change is reversible, right? The matter can be changed back to its original form. I could, put this paper in water, I could grind it all up, and I could actually make a brand new piece of paper out of it, right? Most physical changes are reversible. So pause this video, make sure you've written all that down. So here are some examples of physical changes. And you can write down a few of these in your notebook. Crushing a can is an example of a physical change, right? It still keeps its identity. We could probably straighten it back out. Melting an ice cube, it's still the same thing, right? It used to be ice, now it's water, it's still H2O, it's still the same substance. Same with boiling water, right? We could collect all that evaporated water, freeze it, turn it back into an ice cube. If we mix sand and water, we still have sand, we still have water. Yeah, they're mixed up, but we could probably separate them, right? I could evaporate that water and just leave the sand behind. Breaking glass is an example of physical change. Broken glass, not broken glass, it's still glass, right? Didn't change the identity. It's also reversible. I can melt that glass down and I can make brand new glass. Some of these other ones like chopping wood, physical change. It's still wood. Yeah, now I have two pieces of wood. The shape changed, the size changed, but it's still wood. All right, mixing green and red marbles. The green marbles are still green, the red marbles are still red, nothing changed. All right, so write down a few of those examples, draw a picture to help you understand. Pause this video to do that, and then move on when you're ready. Okay, chemical changes. Now here's where things get interesting. A chemical change is a change to the matter where a brand new substance is created, right? We burn the wood and we end up with ash. That's a brand new substance. Also, the identity, in this case, the identity of the matter does change. Ash is not the same thing as wood. It's got a brand new identity. It's a brand new substance. So the identity does change in a chemical change, so the opposite of a physical change. And finally, chemical changes are irreversible. They are not reversible. Matter can never be changed back to its original form. I can't take a pile of ash and somehow turn it back into a piece of wood. Once I explode a firecracker, I can't turn it back into an unexploded firecracker. Let's look at some more examples. Actually, pause this video, make sure you've written all those down in the chemical change column, and be ready to write down some examples in that chemical change column. So here's some chemical change examples. Rusting iron. A brand new substance is created here. That rust is totally different from the iron of the pan. Burning wood. We're going to go from wood to ash. It's not reversible. We're making a new substance. Metabolism. This is a stomach. So this kind of refers to eating and digesting food. When you eat a piece of pizza, your body digests it and turns it into something else. It turns it into energy. It turns it into other things, right? Energy for you to keep going. Cooking an egg. You can never uncook an egg, right? Once you cook that egg, you can't turn it back into an uncooked egg. It's irreversible. Same thing with baking a cake. You can't unbake a cake, right? Move this down a little bit. Anytime food rots, right? A rotting banana, a rotting apple, you're basically creating a new substance there, and you can't unrot it. Fireworks is an example. Vinegar and baking soda is an example, right? When you mix baking soda and vinegar, you get fizzes and bubbles, creating new substances, and you can't undo that change. All right. So physical changes, you can reverse them, you can change them back. They don't create a new substance. Chemical changes, on the other hand, a brand new substance is created, and there's no going back. Okay. Here's what I mean more about reversible and irreversible changes. So here we have a popsicle. If we heat it up, let's say it's an orange popsicle, right? We heat it up, we're going to get orange juice or frozen or melted popsicle juice. And if we cool it, we're going to go back to that popsicle. We could go back and forth and back and forth and back and forth as many times as we want, because this is a physical change. Anytime we change state from a solid to a liquid to a gas, that is reversible, and we're not creating a new substance, right? Substance in the glass is the same thing as the substance on the stick. It's just a solid versus a liquid. Here's an example of a chemical change, right? Here's an egg. You add heat. It cooks. There's no going back and forth. We can't uncook this egg. Brand new substances are created. It's irreversible, and it's a chemical change. Okay? So make sure you've got all your notes complete, and then move on to the next step in the Google Classroom.